Welcome back to another video. Today we are going to talk about some geometry, in particular about calculating the magnitude of a vector and also finding the angle between vectors using the dot product. So first of all, what is the magnitude of a vector? So if you have a vector, let's call it A with a little arrow above it, A, that's the notation for a vector, is equal to x, y, z, and then the magnitude of this vector is just the square root of x squared plus y squared plus z squared. So that's the formula. And now if we make an example, we can write the vector 1, 2, 3, and then the magnitude, and that's also the length of the vector, is then 1 squared plus 2 squared plus 3 squared, and the square root of all that. So we have 1 squared is 1. Oops. 1 squared is 1 plus 2 squared is 4 plus 3 squared is 9. So we have the square root of 15. So the length of the vector is 15. And another example, let's call the vector t is equal to 4, 2, 1, and then the magnitude. So the length is 4 squared plus 2 squared plus 1 squared, and that's equal to 16 plus 4 plus 1, and that is equal to the square root of 21. So now to the second part, finding the angle between vectors using the dot product. So if you don't remember the dot product, the notation is a dot b, the magnitude a dot b, and if you have a vector a is equal to x1, y1, z1, and a vector b x2, y2, z2, then the dot product is, for this, is in general the magnitude of x1 times x2 plus y1 times y2 plus z1 times z2, and the magnitude of that. So, and if we want to find the angle between vectors using the dot product, we have to use this formula. So we have the cosine of, let's call it alpha, is equal to the dot product a dot b over the magnitude of the vector a times the magnitude of the vector b. And let's do a quick example. So if we have the vector a is equal to 1, 2, 3, and b is equal to 5, 4, 6, then we first have to find out the dot product. So a dot b, and this is equal to 4 times 1 plus 2 times 5 plus 3 times 6, and that's 4 plus 10 plus 18, and that's 32. We don't have to use the magnitude because it's already positive. And now we have to find the length of the vectors. So the length of the vector a is equal to 1 squared plus 2 squared plus 3 squared, and then we take the square root, and that's 1 plus 4 plus 9, and that's 15, so the square root of 15. And for the vector b, we have 4 squared plus 5 squared, 5 squared plus 6 squared, and then the square root. We have 16 plus 25 plus 36, and then we take the square root, and then we get the square root of 77, and then we can plug in our numbers. So we have, just again, we have to use to find the angle between these two vectors. We have cosine of alpha is equal to a dot b over the magnitude of a times the magnitude of b. And now we can plug in. So cosine of alpha is equal to a dot b is 32 over the length of the vector a times the length of the vector b. So we can write this under 1 square root, so 15 times 77. Now to find alpha, we have to use the inverse cosine, so alpha is equal to cosine of 32 over the square root of 15 times 77. And if you plug this in your calculator, you will get approximately 12.9 degrees. And then another example, so if we have the vector a is equal to -2, 0, and 3, and another vector b is equal to 0, -1, 4, we have to use the dot product. That's a dot b, and that's -2 times 0 plus 0 times -1 plus 3 times 4. This is 0 and that is also 0, so we get 12. And then the length of the vector a is -2 squared plus 0 squared plus 3 squared, and the square root we get 4 plus 9, and that's the square root of 13. And then the length of the vector b is equal to 0 squared plus -1 squared plus 4 squared, then the square root, and then we get the square root of 0 plus 1 plus 16, so we get the square root of 17. And then we have to plug in again, so I write it down one more time, over the length of the vector a times the length of the vector b. So we get cosine alpha is equal to 12 divided by square root of 13 times 17, and then we have to use the inverse cosine, so we get alpha is equal to the inverse cosine of 12 over the square root of 13 times 17. And if you plug this again in your calculator, you will get approximately 36.2 degrees. Yeah, I hope you learned something about geometry. I think in the future I will post a little bit more about things I will do I go over in class. Yeah, see you next time.